So here we are, day 9, the second to last day of material that we'll need for the exam that is coming up on Friday the 15th. Today what we're going to be talking about, or what we talked about in lecture, was we talked about amino acids, and I narrowed the scope of the amino acids that you would need to know for this first exam. We're going to go ahead and take a look at that, do some peptide drawing, and ultimately calculate some PIs. So just hang on. Okay, so for this first exam, there are a grand total of 8 amino acid structures that you need to know. They are the aromatics, or they fall into 2 different categories, aromatics and charged. So your aromatic residues are, sorry about that. I'm going to write out the single letter codes, F, Y, W. Then I'm going to write out the 3-letter codes, PHE, TYR, and finally TRP. These are phenylalanine, tyrosine, and tryptophan. Phenylalanine, tyrosine, and tryptophan. Your charged residues, on the other hand, this means that they can either adopt a negative or a positive charge. They are, in alphabetical order, D, E, H, K, R. Aspartic acid, ASP. Glutamic acid, GLU. Histidine, HIS. Lysine, LYS for K, and ARG for arginine. I'm going to write those out. Aspartic acid, glutamic acid, and histidine, lysine, and arginine. What's really important about every single amino acid is to keep in mind what makes them similar and what makes them different from one another. What I recommend is drawing an amino acid at its lowest possible pH. So put it in a solution where the pH is 1, just an absurdly low pH, a very acidic environment. And basically, this is what you're going to look at. So the way that I've drawn this, the R group is going to be the part that varies from amino acid to amino acid. However, these 2 groups on the N termini and the C termini, that's some language that you need to get accustomed to, these are the 2 groups that are going to be common for every single amino acid. Every single amino acid is at very least a diprotic amino acid because there are 2 groups on it that can be protonated and deprotonated. Now we're going to go ahead onto the next page and draw a peptide. So hold tight. Okay, so the first amino acid, or I'm sorry, the first peptide that we're going to draw is FRED. These are all single letter codes for amino acids that you're expected to know. F for phenylalanine, R for arginine, E for aspartic acid, and D for glutamic acid. I'm sorry, reverse those 2. E is glutamic acid and D aspartic acid. Okay, so what do these individual amino acid R groups look like? Well, before we get to that, let's go ahead and draw in our backbone. N, C, C, N, C, C, N, C, C, N, C, C. We're going to draw this peptide at a pH of 1.0. So everything is going to be protonated. What I want to do is I want to draw my backbone and then go in and figure out some things that you will all need to know. What I'm doing in red now is labeling my alpha carbons. And these are the carbons that you will find your R groups on. I'm going to complete my backbone. Each alpha carbon has a hydrogen. So that's 1, 2, 3, and 4. So all of my alpha carbons have their hydrogens. Now what I need to do is go ahead and add the atoms to complete my peptide bond. My peptide bond is from the C termini of one amino acid to the N termini of the next. So I'm going to draw a double bonded oxygen and a hydrogen. Double bonded oxygen and a hydrogen. Double bonded oxygen and a hydrogen. Now, one thing that I would like to echo right now is that each of these groups is appropriately drawn and appropriately protonated despite the pH being at an extremely low 1. So what that means is that the number of hydrogens that are on this N termini, that's accurate. If you look at this nitrogen, or at each nitrogen, aside from our N termini, they'll only have 1 hydrogen. Okay, that's the appropriate number. You do not need to add an extra hydrogen on there or anything of that nature. But now let's go ahead and draw our R groups. And I'm going to switch colors. Let's go to purple. I'm going to go to purple. And what does that actually look like? F is a phenylalanine. And that phenylalanine is going to look like this, CH2. And then we've got 1, 2, 3, 4, 5, and 6. We've got a 6-membered ring. So there is our phenylalanine. R is going to be arginine. Arginine looks like this. CH2, 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 followed by NH, C, double bonded H2N, NH2. Okay, so FR are both done. E is glutamic acid, and that is CH2, CH2, and then C, double bonded oxygen, OH. And finally, D for aspartic acid is CH2, C, double bonded oxygen, OH. So this is our peptide drawn at a pH of 1. What is important to recognize, I'm going to switch over to, let's go to orange, is I'm going to draw a little circle near all of the groups that can be protonated and deprotonated. Oh, and I just realized that my R group, my arginine, I need a positive charge there because that's 4 bonds to that single nitrogen. This is a group that's resonance stabilized. That ultimately can adopt a positive charge. Positive charge, or I'm sorry, no charge on our glutamic acid, no charge on our aspartic acid, and no charge on our C termini. So we have a total of 5 groups that can be protonated and deprotonated. Now what I want you to think about is what are the pKa values for each of these groups. These are numbers that are going to be associated or going to be provided for you, so you do not need to commit these to memory. However, when you're looking at the C termini of this peptide, you need to figure out which pKa value aligns with that C terminal pKa group. And so our final amino acid is aspartic acid. The C termini of aspartic acid has a pKa of 2.09. Okay, the pKa for our R group for aspartic acid is 3.86. Glutamic acid R group is 4.25. Arginine has an R group pKa value of 12.48. And then finally, the N termini of what? Well, the N termini of our N-terminal amino acid, which is phenylalanine, has a pKa of 9.18. Okay, so we have a total of 5 different pKa values that we need to concern ourselves with. What is the charge of this molecule right now? Well, we have 5 different groups, but how many of them actually have a positive charge? The N termini, or I'm sorry, a positive or a negative charge. The N termini, the R group for arginine, but what about the other groups? Aspartic acid, glutamic acid, and our C termini. None of those have charges. They're all neutral. So currently, at a pH of 1, our charge is positive 2. Okay. Now, what I want you to think about is, as you are adding base to this, as you are titrating this this peptide, what are you doing? You are slowly but surely taking off protons. This is the first proton that you're going to take off from the C termini. The next is on your aspartic acid. You're going to take that one off. After that, the proton from your glutamic acid. Now, you've gone from a C termini to R groups, and then you need to go to the N termini. The reason that you go to the N termini is because you are adding base. So your your solution pH is slowly but surely creeping up. You're going from 1 all the way up to 14. So you're picking them off. 2.0, 3.86, 4.25, 9.18, until finally your highest pKa value is 12.48 when you remove a proton from your arginine R group. Okay, so this molecule, this peptide right here, this Fred peptide has a pH, or I'm sorry, in a solution where the pH is 1.0, it has an overall charge of +2. When we are at pH, let's say equals 2.09, what is the charge of the molecule? Well, at that point, we have an equal abundance of the deprotonation here and the protonation here. So if you wanted to look at that, 2.09 is the transition from +2 to +1. Okay. Now, once you go to pH equals 2.10, well, then the predominant form of that molecule has a charge of +1. So what you need to do in order to kind of make some more sense of your R groups, or to make some more sense of your overall charges of your molecules, is to line up these different pKa's. So 2.09, 3.86, and line them up in increasing order. 4.25, 9.18 to 12.48. And when you're looking at this, you should be asking yourself, well, what am I looking at in terms of a transition? When you're looking at 2.09, you're looking at the transition from +2 to +1. 3.86, what are you looking at? You're looking at the transition from +1 to 0. At 4.25, you're looking at 0 to -1. At 9.18, you're looking at -1 to -2, -2 to -3. So a good question that you could ask is, at what pH will this molecule have a -3 charge? And to answer that question, you just have to look at the pKa values. This molecule could have a -3 charge as long as your pH of your solution is above 12.48. Now, what does that actually look like? That means that all of your groups have been deprotonated. Your C termini, your R groups for your aspartic and glutamic acid, your R group for your arginine, and finally the N termini, your N termini for phenylalanine is also deprotonated. So one of the questions that is a very good question to look into is, at what pH does your molecule have a 0 charge? And that's a good question to ask. Ultimately, what that is this is known as the Pi, or your isoelectric point. And in order to do that, what you need to do is you need to get the two values that correlate with this transition from +1 to -1. So in this case, what you want to look at is, where do you go from +1 to 0 and 0 to -1? And you're going to get 3.86 plus 4.25, divide that by 2. So that ends up being something like 7.25 times 8. Let's call that, or what's our difference here? That would be just a hair over 4. So let's call it 4.09 or so. So if pH is equal to this, then 100% of the molecule has a 0 charge overall, a 0 net charge. So this is a slight different way of describing it as compared to what I did in lecture, but they're both acceptable. If I were you, I would work through some practice problems, try to figure out what the Pi is. What you want to do is figure out what is the solution pH where you have no charge, or a 0 charge or 0 net charge on that molecule. So it takes a couple of tries, but there are tons of resources where you can plug in and you can type in a peptide and ask what the Pi is, and it will give you that back. So go ahead and play around with those, play around with this, and make sure that you know how to draw all of these, I guess it was 8 different amino acids, and make sure you know how to draw them as a peptide as well as individually. And I think that'll do it. Anyway, thank you very much for watching. Have a great afternoon.